AICTE PRERANA sponsored um, GATE coaching class for the SC/ST students. So this class is conducted for the benefit of SC/ST students for their higher education. So that we will be giving coaching regarding to the core subjects in chemical engineering. So I welcome you all for this GATE coaching class. So today's session is about fluid mechanics. So fluid statics is what we are going to see today. So myself, V.Santosh, Assistant Professor, Chemical Engineering, Erode Engineering College. So we will be covering the major topics regarding to fluid mechanics. So what is the scope of fluid statics? What are all the applications of fluid statics? So based on that, we will see some of the GATE problems. You have given the solution and the problems. So we'll be discussing one by one. So fluid statics. So fluid mechanics is the study of fluids and their behavior of fluids, as well as we need to study about the properties of fluids. So fluid statics is a branch of science. It's a branch of study. So here we are going to deal about the fluids which are at rest. So fluid statics in the sense study of fluids at rest. Right. So what is the difference between fluid statics and fluid dynamics? So fluid dynamics is nothing but it is the study of the fluids which are in motion. Right. Whereas fluid statics is the study of the fluids which are at rest. Fluids which are taking rest, they are called as fluid statics. Right. So whenever the fluids are at rest, there will not be any shear stress. So there will be only a particular force due to which some kind of a pressure will be present. Right. So that pressure is defined as force per unit area. Right. So the amount of force exerted on the unit area of a substance or on a surface is called as pressure. So we can say we can express the pressure P is equal to F by A. So this is for a finite area. So if you want it for an infinite area, you have to differentiate that. So P is equal to dF by dA. So normally the units of pressure will be so Newton per meter square. So that is nothing but Pascal. So this is the SI unit of pressure. So likewise, CGS and NKS units are given here. Right. So first of all, you should know fluid mechanics is the study of fluids at rest. So it differs from fluid dynamics. So fluid dynamics is nothing but it is the study of the fluid which are in motion. So here we need to concentrate on the pressure. So which is nothing but the amount of the force exerted on a unit area of a substance or on a surface. Right. So the pressure is normally expressed as force per unit area. Right. So fluid statics, the basic law governing the fluid statics is Pascal's law. So we want to know about the Pascal's law. Pascal's law is nothing but um, P is equal to G into H into Z. Right. So Uh, the flow of the fluid will be same in all the directions. That's what Pascal's law is um, all about. Right. So we will be solving equations related to the estimation of pressure, estimation of force, estimation of height, estimation of density. So all those things are problems related to Pascal's law. We will discuss in this class. Right. So we'll take a look at this previous year's gate problem. So the pressure intensity at a point in a fluid is given as 3.924 Newton per centimeter square. So we need to find out the corresponding height of the fluid. So Z is asked here. So when the fluid is water, so two different kind of fluids are given. So one is water and the another one is oil. So oil is having the specific gravity of 0.9, right? So the pressure intensity is given. That is P is given. So that is given as 3.924 newtons per centimeter square. So we need to find out Z. We need to find out Z, right? So Z is nothing but the height of the fluid, right? So first, you can see what is the formula for finding out the height. So Z is equal to P divided by rho into G. So Pascal's law is nothing but P is equal to rho G into Z, right? So as far as this problem is concerned, so we need to identify the corresponding height of the fluid, right? So we can remodify the Pascal's law and you can write it as Z is equal to P by rho into G. So density of water is first fluid is water. So second one is oil. So water's density is constant, that is 1000 kg per meter cube. So you can directly substitute using the formula Z is equal to P by rho into G. So here the pressure intensity is given, that is 3.924 Newton per centimeter square. So you convert that into meter. So 3.924 into 10 to power 4 Newton per meter square. Okay. So Z is equal to 3. P by rho into G. 3.924 into 10 power 4 divided by density of water is 1000 and the acceleration due to gravity is constant, that you know, 9.81. So when you solve, you will be getting uh, 4 meters height. So this is for water, 4 meter of water. So coming to the second part, so they have asked to find out the height of the fluid for oil. So oil specific gravity is given 0.9. So if the specific gravity of a fluid is given, you can easily calculate the density. So the formula is rho is equal to specific gravity into 1000, right? So here density of the oil is equal to 0.9 into, you can take it as rho naught. So 0.9 into 1000. So the density of the oil is 900 kilograms per meter cube. So you can substitute it in that corresponding height of the fluid equation. So Z is equal to P by rho naught into G. So your pressure is 3.924 into 10 power 4. Your density of the oil is 900 and acceleration due to gravity is 9.81. So put together, if you solve, you will be getting 4.44 meters of oil. So this is a simple problem. Every gate question. So this kind of problem related to fluid statics is continuously being asked in each year's gate paper. So be clear about the Pascal's law. So which is nothing but P is equal to rho G into Z. So if you have been asked with density, you need to modify the equation. Rho is equal to P divided by G into Z. If you have been asked the height, so you need to modify the Pascal's law equation. Z is equal to P by rho into G. Right. So we will move on to the next problem. So see here, an oil of a specific gravity 0.9 is contained in a vessel. So at the point, the height of the oil is 40 meter. Again, here they have asked to find out the corresponding height of the water. Right. So oil specific gravity is given. Z is given. Z for that oil is given. So height of the oil is 40 meter. So they have asked the corresponding height of the water. Right. So there is a slight difference between the previous problem and this problem. So here they have given the height of the oil, they are asking the height of the water. Whereas in the previous problem, they have asked the height of the both heights of both the fluids they have asked. So specific gravity of the oil is S naught, that is 0.9. Height of the oil is given, so that is you can take it as Z naught, that is 40 meter. So density of the oil is we have to find out using the specific gravity. So formula is 0.9 into density of water. Specific gravity of the oil into density of water. So that is 0.9 into 1000. So if you have calculated, you could have got 900 kilograms per meter cube. So the intensity of the pressure. So P is equal to rho G into Z. As we already discussed, the Pascal's law is nothing but P is equal to rho G into Z. So here rho naught is given, rho naught into G into Z naught. So 900 into 9.81 into 40 per meter square. 40 newtons per meter square. Okay. So right. So you need to calculate the Z naught here. So Z naught is given. So corresponding height of the water is equal to P divided by density of the water into G. Okay. So 900 into 9.81 into 40. So that is your P actually. So P is nothing but rho naught into G into Z naught. So 900 into 9.81 into 40 divided by density of the water is 1000. Your acceleration due to gravity is 9.81. So if you solve and simplify, you will be getting 36 meters of water. Right. So this is one type of a problem in the fluid statics. So you need to identify the corresponding height of the water. You will be given the height of the oil. Right. So in that you need to remember the formula of P is equal to rho G into Z. Rho into G into Z. Right. So we will move on to the next problem. So you can see the next problem. So this is a very important problem that has been asked in the GATE exam. So an open tank contains water up to a depth of 2 meters, and above it an oil of specific gravity 0.9 for a depth of 1 meter. Find the pressure intensity at the interface of the liquids, two liquids, at the interface of the two liquids. Find the pressure intensity at the bottom of the tank. Right. So here they have given the height of the water. They have given height of the oil. Also they have given. So that is you can look at this figure. So this is an open tank which contains oil and water, both oil and water. So an open tank contains water up to a depth of 2 meter. So up to a depth of 2 meter, here you can see. So the depth of the water, that is height of the water, is taken as Z1. So that is 2, and above that water, the tank is filled with the oil. So which is having a physical gravity of 0.9 for a depth of 1 meter. So oil's height is 1 meter. So you can take it as Z2. So height of the water is Z1, that is 2 meter. Height of the oil is Z2, that is 1 meter. Physical gravity of the oil is given, that is S0, 0.9. So density of the water, you know, that is rho 1 is 1000 kg per meter cube. So how will you calculate if the specific gravity is given? You need to calculate the density using the formula. Density is equal to specific gravity into density of the water. So specific gravity of the oil is 0.9 into 1000. So that is your density of the oil, 900 kg per meter cube. So we already know that pressure intensity at any point is given by P is equal to rho into G into Z. Right. So this is the formula we are going to employ here. So they have asked find the pressure intensity at the interface of the two liquids and at the bottom of the tank. Right. So here at the interface, that is at the point A, you can consider 2 points here, A and B. So the at the interface, that is at the point A, P is equal to rho 2 into G into height of the oil. Right. So you know that the density of the oil. Density of the oil is 900 into acceleration due to gravity is 9.81 into height of the oil. Height of the oil is 1 meter. So you substitute in that formula. So 900 into 9.81 into 1. So that is your what is it? Pressure intensity at the interface of two liquids. That is at the point A. So if you solve, you will be getting 8,829 newtons per meter square. Right. So if you want to change that into Newton per centimeter square, so you need to multiply that by 10 power 4. So if you do that, you will be getting 0.8829 Newton per centimeter square. Right. So next, you need to find the pressure intensity at the bottom of the tank. You need to find out the pressure intensity at the bottom of the tank. Right. So that is at the point B. So if it is at the interface, you need to find. We have already found out the pressure intensity at the interface. That is at the point A. Now we are going to determine the pressure intensity at the point B. Right. So P is equal to. So we need to consider both A and B here. So rho 2 into G Z2 plus rho 1 into G Z1. So be clear while you are calculating the pressure intensity at the bottom of the tank. So you need to consider both the points. You need to consider both the points. So rho 2 into G Z2 plus rho 1 into G Z1. Right. So density of the oil, you know, that is 900. Acceleration due to gravity value is constant. So height of the oil also, you know. Likewise, the density of the water, we know that 1000 kg per meter cube acceleration due to gravity into height of the water. So you can directly substitute 900 into 9.81 into 1 plus 1000 into 9.81 into 2. So put together you will be getting 28,449, 28,449 Newton per meter square. So as like that in the previous case, so if you want to convert that into Newton per centimeter square, you can divide that by 10 power 4. So you'll be getting around 2.8449 Newton per centimeter square. So this is one type. So they will be asking the height of the fluid by giving the density in the first case. So second case we have asked we have been asked with what is that? So you need to find out the height of the fluid. So pressure intensity and oil's height is given. So that is the second case. In the third case, they will be asking the pressure intensity at the interface of the two liquids as well as at the bottom of the tank. Right. So this is one important type as well in the fluid statics. So next you can see. So this is a problem related to the determination of load. Right. So take a look at this problem. So the diameters of a small piston and a large piston of a hydraulic jack at 3 centimeter and 10 centimeter respectively. A force of 80 Newton is applied on the small piston. So we are applying a force on the small piston. So the value of the force is given. So that is 80 Newton. So we need to find out the load lifted by the large piston when the pistons are at the same level. That is the first case. When the small piston is 40 centimeter above the large piston, that is the second case. So two different cases are here. So when the diameters of the two pistons, when the pistons are at the same level, we need to find out the load lifted by the large piston. Likewise, when the small piston is 40 centimeter above the large piston, we need to identify what amount of load is lifted by the large piston. So density of the liquid in the jack is given as 1000 kg per meter cube. Right. So you can see this figure. So this is the large piston and the small piston. So on the small piston, 80 Newton force is applied on the small piston. So we need to find out the load lifted by the large piston when both the pistons are at the same level. So in the second case, if the small piston is 40 centimeter above the large piston, what will be the load lifted by the large piston? So that is what we have been asked in this problem, right? So whenever you are getting this type of problem, first of all, you should find out the area of both the pistons. So depending upon the diameter, you need to find out the area. So the diameter of both the small pistons and large pistons are given. So you know that. So what is the diameter of the small piston? So take it as small d. So diameter of the large piston is to take it as capital D. So diameter of the small piston is d is equal to 3 centimeter. You can find out the area. So A is equal to pi by 4 into d square. So pi by 4 into diameter is 3. So 3 square. So you will be getting the area. So area here is 7.068 centimeter square. So this is for small piston. Likewise, you need to do it for large piston. Take it as capital D. So the area of the large piston is, diameter of the large piston, D is equal to 10 centimeter. So same formula, capital A is equal to pi by 4 into D square. So you can calculate. So that is around 78.54 centimeter square. So what is the force given? So force on the small piston, capital F is equal to 80 Newton. So we need to find out the load. So take it as W. So first case is when the pistons are at the same level. So when the pistons are at the same level. So pressure intensity on small piston. So pressure is expressed as force per unit area, F by A. Right. So what is force exerted on the small piston? 80 Newton. So 80 divided by area of the small piston in 7.068. So 7.80 by 7.068 Newton per centimeter square. Right. So this means this kind of force per unit area is transmitted equally on the large piston. Right. So next we want to write the pressure intensity on the large piston. So that is also 80 by 7.068. So there will be an equal transmission on the large piston. So that is also 80 by 7.068. Okay. Since the pistons are at the same level. So now we want to calculate the force on the large piston. So it is equal to pressure into area. Right. So pressure is given by F by A, that is 80 by 7.068 into area of the large piston. What is the area? We have already determined 78.54 Newton. So 80 by 7.068 into 78.54. So that is your force on the large piston when the pistons are at the same level. Since the pistons are at the same level, there will be equal transmission, equal amount of pressure transmission on the large piston. Right. So you will be getting 888.96 Newton. So this is for the first case. So what is the second case? So find the load lifted on the large piston when the small piston is 40 centimeters above the large piston. You can take a look at this figure. So when the small piston is 40 centimeters above the large piston. Right. So when the small piston is 40 centimeters above the large piston. So pressure intensity on the small piston that we know, that is force by area, F by A, 80 by 7.068 Newton per centimeter square. So you can draw, you can take this section AA. So pressure intensity at the section AA is F by A plus pressure intensity due to the 40 centimeter height of the liquid. So you need to add that pressure intensity due to 40 centimeter height of the liquid to the pressure intensity of the small piston. So that is the pressure intensity at the section AA. So F by A plus pressure intensity due to height of 40 centimeter of the liquid. So what is the pressure intensity due to 40 centimeter of the liquid? So P is equal to rho into G into H. So which is equal to density of the water is what? 1000. 9.81 into what is the height? 0.4, 40 centimeters. So 0.4. So you calculate now. So you need to convert that into 10 to the power of centimeter square. So divided that by 10 power 4. So 1000 into 9.81 into 40 divided by 10 to the power of 4. So that is the pressure intensity due to 40 centimeter of the liquid, right? So you need to add that pressure intensity due to height of 40 centimeter of the liquid to the pressure intensity on the small piston, that is F by A, 80 by 7.068, right? So what is the answer? If you have calculated, you will be getting pressure intensity due to 40 centimeter of the liquid is 0.3924 Newton per centimeter square. So pressure intensity at the section AA is equal to F by A plus pressure intensity due to height of the 40 centimeter of liquid. So 80 divided by 7.068 plus 0.3924, that is nothing but the pressure intensity due to 40 centimeter of the liquid. So you will be getting 11.71 newtons per centimeter square. So this is the pressure intensity transmitted to the large piston. When the piston is, small piston is 40 centimeter above the large piston, right? So force on the large piston we need to determine. So F is equal to pressure into area. So P is equal to F by A. So F is automatically P into A, right? So pressure is 11.71. That is a pressure intensity transmitted to the large piston into area of the large piston, capital A. So area of the large piston is we have already determined 78.94. Right. So 11.71 into 78.54. So that is 919.7 Newton. Right. So this is a very important type of problem which will be asked in the GATE exams. So you should know how to calculate the pressure intensity. Right. When both the pistons are at the same level and when the pistons are having difference in height. So two cases you should note here. Right. So we'll move on to the next problem. So here we are going to speak about the gauge pressure and absolute pressure. So this is a manometer regarding problem. So pressure measurement. Right. So what are the gauge pressure and absolute pressure at a point 3 meter below the free surface of the liquid, having a density of 1.53 into 10 power 3 kg per meter cube. If the atmospheric pressure is equal to 750 mm of mercury, the specific gravity of mercury is 13.6 and the density of the water is 1000 kg per meter cube. Right. So they have asked the gauge pressure and absolute pressure here. So at a point 3 meter below the free surface of the liquid. So density is given, that is 1.53 into 10 power 3 kg per meter cube. So which is equivalent to the 750 mm of mercury. Specific gravity of the mercury is also given, density of the water is given. So they have asked the gauge pressure and absolute pressure. So right. So depth of the liquid is given, that is Z1 is 3 meter density of the liquid rho 1 is equal to 1.53 into 10 power 3 kg per meter cube. Right. So what is the absolute pressure head? So they have given us 750 mm of mercury. So Z0 is equal to 750 mm of Hg. So if we want to convert that into meter, so you need to divide that by divided by 1000. So 750 by 1000 is equal to 0.75 meter of mercury Hg. So first you find out the atmospheric pressure. So atmospheric pressure is equal to rho into G into Z. So rho naught into G into Z naught. So rho naught is the density of the mercury. So depending upon the specific gravity, based on the specific gravity of the mercury, we can easily determine the density of the mercury. So specific gravity of the mercury is given, that is 13.6. So to calculate the density of the mercury, so 13.6 into 1000. That is your uh, density of the mercury, right? So Z naught is pressure head in terms of mercury, right? So atmospheric pressure is equal to 13 rho naught into G into Z naught. So 13.6 into 1000 into 9.81 into Z naught is 0.75 into 0.75, right? So if you calculate, you will get the atmospheric pressure value as 1,000,62 Newton per meter square. Right. So roughly it is 1,62 Newton per meter square. That is your atmospheric pressure. You have calculated based on the formula P is equal to rho G into Z. So this is the first step. Right. So next, they have asked to find out absolute pressure. For determining absolute pressure, you need to have gauge pressure and atmospheric pressure. For the purpose only, we are calculating atmospheric pressure here. Right. So what is the formula of absolute pressure? So absolute pressure is equal to gauge pressure plus atmospheric pressure. So we have determined the atmospheric pressure. That is the first step. Second step is to determine the gauge pressure using the given data. So pressure at a point which is at a depth of 3 meter from the free surface of the liquid is given by P is equal to rho 1 into G into Z1. Right. So density of the liquid below the free surface is 1.53 into 10 power 3. So 1.53 into 1000 into 9.81 into height. What is the height given? Height is given as 3, right? So 1.53 into 1000 into 9.81 into 3. So that is your pressure, right? So you'll be getting 45,028 Newton per meter square. So that is your gauge pressure, right? So you have calculated atmospheric pressure and you have calculated gauge pressure. So now you can easily determine the absolute pressure. Absolute pressure is equal to gauge pressure plus atmospheric pressure, right? So what is your gauge pressure value? 45,028 plus atmospheric pressure we have already determined, that is 1,62. So you can add both. So that value is your absolute pressure. So you'll be getting 90 Newton per meter square. This is a very, very important problem. We have been asked about the absolute pressure. So the formula for calculating atmospheric pressure is, atmospheric pressure is P is equal to rho into G into Z. So based on that, you can easily calculate atmospheric pressure and the gauge pressure. So once you have calculated gauge and atmospheric pressure, you can easily calculate absolute pressure. Absolute pressure is gauge pressure plus atmospheric pressure. Right. So we will move on to the next problem. So here, this is the estimation of pressure related problem, right? So the right limb of a simple U-tube manometer containing mercury is open to the atmosphere, while the left limb is connected to a pipe in which a fluid of specific gravity 0.9 is flowing. The center of the pipe is 12 centimeter below the level of the mercury in the right limb. Find the pressure of the fluid in the pipe if the distance of mercury level in the two limbs is 20 centimeter. So, uh, so this is a U-tube manometer related problem. You have been asked with the pressure of the fluid. You need to determine the pressure of the fluid, right? So what is given? So the right limb of the U-tube manometer is open to the atmosphere. You can see here. The right limb is open to the atmosphere, and the left limb is connected to a pipe. So they have connected the left limb to the pipe, so that pipe is containing a fluid whose specific gravity is 0.9. That is given. The center of the pipe is 12 centimeter below the level of the mercury. You can see this figure. So the center of the pipe is 12 centimeter below the level of the mercury in the right limb. To find the pressure of the fluid in the pipe if the difference of mercury in the two limbs is 20 centimeter. Mercury level difference 20 centimeter. If in that case, you need to determine the pressure of the fluid. So what is the specific gravity of the fluid given? Say S1 is equal to 0.9. So based on that, you can easily calculate the density. Density of the fluid rho 1 is equal to S1 into 1000. So that is 0.9 into 1000, 900 kgs per meter cube. What is the physical gravity of mercury? So that is S2, 13.6. So based on that, you can calculate the density of the mercury. So that is 13.6 into 1000. So what is the difference of mercury level? That is 20 centimeter. That is given. So you can take it as H2. So that is 20 centimeter, which is nothing but 0.2 meters. What is the height of the fluid from the section AA? So that is 12 centimeter. Sorry, that is you need to calculate the height of the fluid from the section AA. So that is H1 is that will be taken as H1. H1 is equal to 20 minus 12. So that is 8 centimeters. That is nothing but 0.08 meters. So now we need to determine the P, that is the pressure of the fluid in the pipe, right? So P plus rho 1 GH1 is equal to rho 2 GH2. So that is what that is what they have asked. So this is the equation to determine the pressure of the fluid. So P plus rho 1 is 900 into 9.81 into H1 is 0.08. So that is the height of the fluid from the section AA. So it is equal to rho 2 13.6 into 1000 into 9.81 into H2 is height of the difference in mercury level, that is the H2 0.2. So P is equal to 13.6 into 1000 into 9.81 into 0.2. So we can bring this term to the right hand side. So minus 900 into 9.81 into 0.08. So you will be having the pressure value if you do in this scenario, in this manner. So P is equal to 2. So you'll be getting in Newton per meter square. That is 25,977 Newton per meter square. So if we convert that into centimeter, so you'll be getting 2.597 newtons per centimeter square. Right. So this is one type of the problem related to pressure calculation in the YouTube manometer. Right. So you can see the another problem where they have asked the vacuum pressure. Where they have asked the vacuum pressure in the pipe. So you see the problem. A simple YouTube manometer containing mercury is connected to a pipe in which a fluid of specific gravity 0.8 and having vacuum pressure is flowing. The other end of the manometer is open to the atmosphere. Find the vacuum pressure in the pipe if the difference of mercury level in the two limbs is 40 centimeter and the height of the fluid in the left from the center of the pipe is 15 centimeter below. Right. So as like the previous problem. So one end of the manometer is open to the atmosphere, another end of the manometer is connected to the pipe. So which will be having a fluid flowing inside. So the specific gravity is given 0.8 and the vacuum pressure is flowing inside that pipe. So they are asking what amount of vapor pressure is in the pipe. If the difference in mercury level is 40 centimeter in the two limbs and the height of the fluid is in the left from the center of the pipe is 15 centimeter below. Right. So very simple. So first you write the given data. So specific gravity of the fluid S1 is 0.8. Specific gravity of the mercury S2 is 13.6. What is the density of the fluid? So 0.8 into 1000. So that is 800. So next density of the mercury is 13.6 into 1000. The difference of mercury level H2 is given as 40 centimeters. That is 0.4 meters. The height of the liquid in the left limb is given as 15 centimeter. That is you can take it as H1. So is equal to 15 centimeter. That is 0.15 meter. So pressure in the pipe we can take it as P. So we need to equate the pressure in the section AA. So that is above the datum line. So rho 2 GH2 plus rho 1 GH1 plus P is equal to 0. Right. So they are asking the vacuum pressure, that is P here. So keep P in the right hand side and bring all those terms, first two terms to the left hand side. So we'll be getting minus of rho 2 GH2 plus rho 1 GH1. Right. So rho 2 is 13.6 into 1000 into 9.81 into H2. That is the height of the difference of mercury level. That is H2 0.4 plus 800 into 9.81 into 0.15. That is the height of the liquid in the left limb. So if you calculate, you will be getting minus 54,543.6 Newton per meter square. So if we convert that, you'll be getting minus 5.454 Newton per centimeter square. So based on the YouTube manometer, pressure measurement is a very important type as far as gate exams are concerned. So you concentrate on that pressure measurement problems to solve a number of problems. So this is one of the examples we are solving in today's class. So we'll be solving a number of number of problems in the upcoming class. Right. So going to the next problem. So a YouTube manometer is used to measure the pressure of the water in a pipeline, so which is in excess of the atmospheric pressure. A YouTube manometer is used to measure the pressure of the water in a pipeline, which is in excess of the atmospheric pressure. So the right limb of the manometer contains mercury and is open to the atmosphere. So the contact between water and the mercury is in the left limb. Determine the pressure of the water in the main line. If the difference in the level of the mercury in the limbs of U-tube is 10 centimeter, and the free surface of the mercury is in level with the center of the pipe. So if the pressure of the water in the pipeline is reduced to 9,810 Newton per meter square, calculate the new difference in the level of the mercury. Right. So what is asked? You need to calculate the difference in level of the mercury. So what they have said in this problem. So YouTube manometer we are using to measure the pressure of the water. So the pressure of the water is in excess of the atmospheric pressure. So the right limb of the YouTube manometer is containing mercury, and the right limb is open to the atmosphere. The contact between water and mercury is in the left limb. Contact between water and mercury is in the left limb. So we need to determine the pressure of the water in the main line. So the difference in level of the mercury of the U-tube is 10 centimeter. So on free surface of the mercury is in level with the center of the pipe. Okay. So suppose if in the case the pressure of the water in the pipeline is reduced to 9,810 Newton per meter square, what will be the new difference in the level of the mercury? So that is what they have asked. Right. So you can see this figure. So this is the right limb. This is the left limb. So the left limb is filled with mercury. So right limb is filled with mercury. Left limb is filled with water. So you can consider 4 different points here: A, B, C, and D. So the difference in level of the mercury in the limbs is 10 centimeter. That is, you can see from this figure, right? So you write the difference in mercury level is 10 centimeter. That is 0.1 meter, right? So you can take the pressure of the water in the pipeline as pressure of the water in the pipeline. That is at the point A as PA, right? So the you can see the points B and C lies on the same horizontal line, right? So whatever the pressure at B, that will be same as the pressure in the point C. So both the pressures at the point B and C will be same, since both points are lying in the horizontal line, right? So now, but the pressure at B, how the pressure at B will be? Pressure at B is equal to pressure at A plus pressure due to 10 centimeter rise difference in mercury. So pressure at B is equal to pressure at A plus 10 centimeter pressure due to 10 centimeter or 0.1 meter of water. So which is equal to PA plus pressure due to 10 centimeter of water is rho into G into H, right? Rho is your density of the water, that is 1000. H is your difference of mercury, that is 0.1. So PA plus 1000 into 9.81 into 0.1, which is equal to PA plus, if we simplify this, 991 Newton per meter square. So pressure at C is equal to pressure at D plus, so likewise we need to calculate the pressure at the point C. So that is nothing but pressure at D plus pressure due to 10 centimeter of mercury. Right. So pressure at D is automatically there will not be any pressure at D. So that is 0. So pressure due to 10 centimeter of mercury is rho naught into G into H naught. Right. So density of the mercury is given. So that is 13.6 into physical gravity is given 13.6. So we need to find out the density. So 13.6 into 1000. So H naught is 10 centimeter, that is 0.1 meter. So we can substitute now pressure at D plus pressure due to 10 centimeter of mercury, that is 0 plus rho naught into G into H naught. So 0 plus 13.6 into 1000 into 9.81 into 0.1. So that is your pressure at C. You will be getting 13,341.6 Newton. Right. So, but pressure at B is equal to pressure at C. So we need to equate both the equations. So you can take that pressure at B as equation 1 and pressure at C as equation 2. So PA plus 981, which is equal to 13,341.6. So PA is equal to 13,341.6 minus 981, which is nothing but 12,360.6 Newton per meter square. What is the second part they have asked? They have asked if the pressure of the water in the pipeline is reduced to 9,810 Newton per meter square, calculate the new difference in the level of the mercury. Right. So the pressure at the point A is reduced to 9,810 Newton per meter square. Right. So you need to find out the pressure difference in the mercury level. So you can see here. So the pressure is reduced to 9,810 difference 10 Newton per meter square. What will be the new difference in mercury level? So you can consider here these three different points: B star, C star, and D star. The difference between this point is 10. Difference between this is you can take it as 10 minus x, and the difference between this C star and D star is 10 minus 2x. Right. So in this case, the pressure at A is 9,810 meter square, which is less than the pressure at A. Right. So you can say the rise of the mercury in the left limb will be equal to the fall of the mercury in the right limb. So since the total volume remains same, right? So you can take x as the rise of the mercury in the left limb, fall of the mercury in the right limb is equal to x centimeter, right? So the points B, C, and D shows the initial condition, and points B star, C star, and D star shows the final conditions. Right. So now you need to calculate the pressure at B. So what we have said, since both the B and C lies in the horizontal line, the pressure at B and C will be the same. Likewise, the pressure at B star is equal to pressure at C star, or you can say pressure at A plus pressure due to 10 minus x centimeter of water. This is equal to pressure at D star plus 10 minus 2x centimeter of water. Pressure due to 10 minus 2x centimeter of water. So if you equate PA plus rho 1 into G into H1, which is equal to PD star plus rho 2 into G into H2. So what is PA? So the 1910. Right. Plus 1000 into 9.81 into height is 10 minus x divided by 100. So which is equal to pressure at D star will be 0 plus pressure due to 10 minus 2h into 2h centimeter of mercury. So that is rho is 13.6 into 1000 into 9.81 into 10 to the power of 10 minus 2h divided by 100. So if you divide that by 9.81, so we'll be getting, you have to equate that problem, right? So you'll be getting the value of x as 0.992 centimeter. So new difference of mercury is 10 minus 2x. So you have determined the x. So that is the x is nothing but the rise of mercury in the left limb or fall of the mercury in the right limb. So 10 minus 2 into 0.992. So that is your new difference of mercury, right? So these are the problems related to Pascal's law and manometer related pressure measurement problems. So in this class, we have seen the gate problems related to fluid statics. So mainly we have focused on Pascal's law and we have focused on the pressure estimation and force estimation problems, and also we have seen the YouTube manometer related problems where how to calculate the absolute pressure when the atmospheric pressure and gauge pressure is given, and how to estimate the height of the liquid, the density and um, pressure is given, how to determine the pressure intensity if the density and height is given. So likewise, we have seen the problems related to YouTube manometer for the pressure measurement also, right? So hope you all have understood all the problems that we have discussed in today's class. Uh, so this is class. This class is for the betterment of the students who are going for higher education. So uh, thank you all. See you in the next session. Thank you.